Hello students, welcome to EDAMIGO, an initiative by GATE ECE Top 3 Rankers. I welcome you all to the lecture series on previous year GATE questions on the topic that is signals and systems. And in this video lectures, we are starting with the previous year questions on signals and system of electronics and communication branch. The topic of this part of the lecture series is basics of signals and systems, and in this we will include the previous year questions of LTI systems also. So let's begin the part 1 of the lecture series. So this is the question. In this lecture series I will be solving the question as well as giving you the concepts, that is the concept on which the questions are based. So in this question a signal is given and we have to find the fundamental time period, and it is important to mark that we have to give the answer in seconds. So let's see the concept of the question. The pattern of the question is a signal capital XT is given as a sum of individual signals, that is x1t, x2t, x3t and so on. We have to find the period of the signal. Okay, so we have to find the period of the signal, and also we have to find that is the signal periodic or not. Is the signal periodic or not? Okay, so let's solve the concept first. Let me give you the concept first. So we have a signal that is capital XT written in the terms of sum of individual signals, that is x1t, x2t, x3t. So to find the period of capital XT and to find that is capital XT periodic or not, we will follow this method. So I will give you the method to solve such questions. So step number 1. Step number 1 is, if any of the individual signals are x1t, x2t and x3t, that is x1t, x2t, x3t is non-periodic, then capital XT is non-periodic. If all are periodic, then move to step 2. Okay, now let me write the step 2. Step 2. Now if any of the individual signal is DC, DC means it's a constant, then neglect that signal. I can neglect that signal because it will not affect the period of capital XT, and find the time period of remaining individual signals. So remove the DC signals and find out the time period of the remaining individual signals. So let us say that x1t has time period t1, x2t has time period t2, x3t has time period t3 and so on. Similarly x4t has time period t4 and so on. Now step 3. Now find these ratios. So find these ratios. Ratios are T1 upon T2, T1 upon T3, T1 upon T4, T1 upon T5, and so on. Okay. Now a very important point is that if any of the ratio is not in the form of integer upon integer, then capital XT is non-periodic. Okay. Okay. So this is a very important point. If any of the ratio is not in the form of integer upon integer, then capital XT is non-periodic. That is very important. Okay. If all the ratios are integer upon integer, then move to step 4. Okay. Now let's look at step 4. Now find the LCM of denominators of the ratios. Okay. So ratios found in step 3. So in step 3 we have found the ratios. Now we will find the LCM of all the ratios, and let the LCM is X. Now let me add a point here. If all the ratios are integer upon integer, then capital XT is, okay, I will add a point here. Then capital XT is periodic, and to find the period, move to step 4. Now in step 4 we have found the LCM of the denominators, and we said that the LCM is X, and the time period of capital XT, that is T0, is equals to X into T1. Okay. So this is the solution of such kind of questions. Okay. Now let's look at the question given to us. Ft is equals to 1 plus 2 cos pi t plus 3 sine 2 pi by 3t plus 4 cos. Oh, let me write it now in one single line so that things are easier. Okay. So let me write in one single line. Okay. So it is given that Ft is equal to 1 plus 2 cos pi t plus 3 sine 2 pi by 3t plus 4 cos pi t by 2 plus pi by 4. Okay. Now we can see that the individual signals, all the individual signals are periodic, and this individual signal is DC, so we will remove that. Okay. And all the other individual signals are periodic, so we will move to step 2. Now in step 2 we find the time period of the signals. So the time period of this is T1, that is equal to, since omega naught is equal to pi, so time period is equal to 2. Okay, let me tell you that cos omega naught t plus theta has time period 2 pi by omega naught. Similarly, sine omega naught t plus theta has time period 2 pi by omega naught. Okay, I will have to add a page here. Okay, now using the formulas we can say that t1 is equal to 2, t2 is equal to 2 pi divided by 2 pi by 3, that is 3, and t3 is equals to 2 pi divided by pi by 2, that is 4. Now we will find the ratios, that is t1 upon t2, that is 2 by 3. This is ratio number 1. Another ratio is t1 upon t3, that is 2 upon 4, that is 1 upon 2. Now since both these ratios are integer upon integer, so the signal ft is periodic, and the next step number 4, we will find the LCM of the denominators. Now the denominators are 3 and 2. So the LCM of 3 comma 2 is 6. So x is equals to 6, and time period t0 will be x into t1, that is 12. So 12 is the answer to the question, and I have explained you how to solve such questions in a very thorough manner. Okay, so this is the solution to the question. Now let's move to the another question. It's a very simple question. Given that u is the input and y is the output of the system, we have to find which of the system is non-linear. Okay. Now to check the linearity of any system, we check that is the system equation is satisfying the superposition theorem or not. So let me tell you what is superposition. So to check linearity, we check that is the system equation satisfying the superposition theorem or not. If it is satisfying superposition theorem, then it's a linear system. If it is not satisfying, then it's a non-linear system. So what is superposition theorem? What is superposition theorem? The superposition theorem states that if the system has input x1t and output is y1t, if the same system has input x2t and output is y2t, then if the input is ax1t plus bx2t, then if the output is a times y1t plus b times y2t, then the system follows superposition theorem and it is a linear system. Okay, so for x1t output should be y1t, for x2t output should be y2t. Now we have to check that if the input is ax1t plus bx2t, and if we found that the output is ay1t plus by2t, then the system follows superposition and the system is linear. Okay, now we will solve the question with taking C and D as first. Okay, so let us check that is the C option given to us is linear or not. So it is given that y is equal to AU plus B. Okay, so this is the output and U is the input. So this equation can be written as, this is very important. Okay, this step is very important. This equation can be written in statement format, that output of the system is equal to A multiplied by the input plus B. Okay, so this is the statement form of the equation. Okay, the same equation written in the statement form. Now if we give input as x1t, or not x1t, let us say if the input is u1, then the output y1 will be equal to, using this statement, y1 is equal to A times u1 plus B. If the input is u2, then output y2 will be equal to A times u2 plus B. Okay, using this equation, that the output is equal to A times input plus B. Now let us say that we applied input CU1 plus DU2. Okay, where C and D are the constants, U1, U2 are the signals. Okay, then the output y out will be equal to A times input. So what is the input? Input is this CU1 plus DU2 plus B. That is equals to ACU1 plus ADU2 plus B. And we can see that this is not equal to A times y1 plus, sorry, this is not equal to C times y1 plus D times y2. Okay, and thus the system is not following the superposition theorem, and thus this is a non-linear system. Okay, now let's check the D option, y equal to AU. This can be written as output is equal to A times input. Okay, so it's a very simple to solve. For u1 the output will be y1, that is AU1. For u2 the output will be y2, that is AU2. For CU1 plus DU2 the output will be y out, that is equals to A times input, that is CU1 plus DU2, that is ACU1 plus ADU2, that is C times of y1 plus D times of y2, and thus we can say that this is a linear system because it is following the superposition theorem. Now if we look at option number 2, I'm just solving it so that the question is complete, otherwise the answer is already there, that is C is the correct answer. Now let's look at option number B. Okay, so option B is yt equals to 0 to, so let me see it again, 0 to t e to power alpha t minus tau beta u tau, 0 to t e to power alpha t minus tau beta u tau d tau. Okay, now if you know that what is the formula of convolution, ht convolve xt is equal to minus infinity to infinity h of t minus tau x tau d tau. Okay, now if we compare this formula, then we can say that Comparing this, we can say that x tau is equal to beta u tau, and because of u tau, this integration is starting from 0, otherwise it should start from minus infinity. Okay, now since x tau is beta u tau and u tau is 0 for t less than 0, so that's why the lower limit is not minus infinity, the lower limit is 0. Okay, now the upper limit is also, here the upper limit is t, but here the upper limit is infinity in the convolution formula. So from here we can say that since u tau is equal to 1 for from tau equal to 0 to tau equal to infinity, so this cannot limit the integration, so the integration will be limited by this. So we can say that h of t minus tau is equals to e to power alpha t minus tau for tau less than t. Okay, are you getting the point? Because the integration limits are changing, that here the integration limit is minus infinity and infinity, but here the limit is 0 and t. So why the lower limit is 0? Because of u tau, because u tau is 0 for tau less than 0. So that's why this 0 is coming due to this u tau, but this t is coming due to this second term, and thus we can say that h t minus tau is equal to e to power alpha t minus tau for tau less than t, and it is 0 for tau greater than t. Okay, so this is that. Now we can say that, now since here the variable is tau in both the equations, so we can say that in this equation, if we put t equal to 0, because t is a constant in this equation, right? So we can say that x tau is equal to beta u tau, and h minus tau is equal to e to power minus alpha tau, tau less than 0, and 0 for tau greater than 0. So h tau will be equal to e to power alpha tau for tau greater than 0 and 0 for tau less than 0. Okay, so these are the two equations of x tau and h tau. Okay, so now we can say that yt is equals to xt convolve ht, where xt is equals to beta ut and ht is equals to e to power alpha t ut. Okay, and as we know that convolution is always a linear operation, so this system is always a linear system. This is B. Okay, this is a linear system. Okay, we can solve this using superposition also. Okay, so we have seen that yt is a convolution of two signals, so convolution is always a linear operation, so this is a system which is linear, but we can solve it using the superposition also. So let me solve it using superposition. Here yt is equals to 0 to t e to power alpha t minus tau u tau d tau. Okay, so in the statement form we can say that output t is equals to 0 to t e to power alpha t minus tau input tau d tau. Okay, so we can say that u1t is the input, then output y1t will be equal to 0 to t e to power alpha t minus tau u1 tau d tau. u2t is the input, then output y2t is equal to 0 to t e to power alpha t minus tau u2 tau d tau. Now let us give the input as a times u1t plus b times u2 t. So this is my input t. Okay, so the output y out t will be equal to, so using this statement of the system, we can say it is equals to 0 to t equal to 0 to t e to power alpha t minus tau input tau. So input t is this, so it is a u1 tau plus b u2 tau d tau, and we can see that this is equal to a times y1 t plus b times y2 t. Okay, so since the system is following superposition, so it is a linear system. Okay, I will have to add a page here because I am explaining you each and every option, so that's why it is taking more time. So let us say see option 1. Now, option A is triple differentiation of output with respect to time, double differentiation of output with respect to time, single differentiation of output, and the output is equal to B3U, that is input, plus single differentiation of input plus double differentiation of input. So this is the relationship given to us. Now we can easily solve that when U1 is input and Y1 is output, then what will be the relationship? The relationship will be Y1 triple dash A1 Y1 double dash A2 Y1 dash A3 Y1 is equal to B3 U1 B2 U1 dash plus B1 U1 double dash. So this is equation number 1. Now when U2 is input and Y2 is output, then Y2 triple dash plus A1 Y2 double dash A2 Y2 single dash plus A3 Y2 is equal to B3 U2 B2 U2 dash plus B1 U2 double dash. Now let us say that now the input is A times, not A, let's use another variable. So let the input is C times U1 plus D times U2 and output is Y out. Okay, so Y out triple dash A1 Y out double dash A2 Y out single dash A3 Y out is equal to B3 CU1 plus DU2 plus B2 CU1 dash plus DU2 dash plus B1 CU1 triple double dash plus DU2 double dash. Now we can say that this expression is actually equal to the sum of RHS of equation number 2 and equation number 3. So we can say that Y out triple dash plus A1 Y out double dash plus A2 Y out dash plus A3 Y out, since this is equal to the sum of RHS of equation 2 and equation 3, so we can write the sum of LHS also in the RHS of this. So we can write here that it is equal to Y1 triple dash plus A1 Y1 double dash plus A2 Y1 dash plus A3 Y1 plus y2 triple dash plus a1 y2 double dash plus a2 y2 single dash plus a3 y2. Now if we compare the RHS and LHS, we can say that it will be equal to C times this and D times this. Okay, because we can see that C and D are the variables which are present here. So we can say that y out is equals to C times y1 plus D times y2. So we can say that this equation also follows the linearity property. Now let me tell you one very important point is that we used to study linear differential equations in mathematics. The linear differential equations are of the format summation ak, the kth derivative of y is equals to summation bk, the kth derivative of another variable, let us say u, and k is going from 0 to, for example, capital N, k is going from 0 to capital M. Such kind of equations are always linear, are always producing the linear system, because these equations are the linear differential equations. Okay, there should not be any constant in addition in RHS or LHS in such equations. Okay, so these equations are linear differential equations and they always produce a linear system. So this equation is a linear differential equation, you can see that. Okay, so that's why it is a linear system. Okay, so I stop here. This is part 1 of the lecture series on the topic 1. Okay, so we'll be continuing this topic 1 in the next part. Thank you. Stay tuned and keep sharing these lectures and subscribe to the channel. Thank you.